So thank you for coming today. I'm honored you picked this session to jump into, and I'm excited to share some things here. My name is Stephen Mizell, and you are in the session around finding ways to measure complexity of an API design. And a little bit about me, I have been working in the API industry since around 2014. For API tooling companies. Before that, I had worked building APIs and just fell in love with the topic and ended up trying and starting to build tools with some of these companies. And now I'm doing some consulting work and working with some companies like Superface and Optic, who are both doing some really cool things. You should check them out. A really quick plug as well. I am releasing a book this Thursday around this same topic of complexity. I won't be covering everything in the book, and I will actually be covering some stuff today that is not in the book to try to make it a little fresh. But if this is of interest to you and you are wanting to go deeper into some of the things I'm discussing, please check it out. You can pre-order until Thursday, and you can get a discount with the pre-order code early dash bird. I'll put the link to my page here. I don't really have slides, but I have a page where I'm going to be talking and showing some things. So let's dive in. I'm talking today about complexity in APIs, and I think it's a really interesting topic because I think it would be really interesting for us to find ways to deal with complexity. It's one of those things that's hard to put your finger on. It's hard to find ways to talk about it. And as I started thinking about and talking about it, the biggest problem that or the biggest challenge that I have felt is that most of the time with complexity, we are only experiencing it in after we put it into our API designs. A lot of times it's a feel thing. A lot of times it's something we experience or our consumers experience as they try to use the API. So this is, to me, one of the big problems is the big challenges is trying to find ways to shift that so that we're able to see and feel and experience complexity much earlier so that we can manage it better. I mentioned a couple of things here that a lot of times this happens when a consumer will get to a point where they are frustrated with using the API or they can't find the way to get the value out of the API. And other times, if you're the provider for the API, you may feel a bit worried in that you're going to break something when you change it. It just feels very brittle. It feels like if you change something over here, it's going to break something else over there. So I feel like that's our biggest challenge is we don't really know what we are doing as we make changes. A big part of the way complexity works is that it kind of builds up over time, and it's sometimes can build up undetected. It's hidden from us. I have a little graphic here, if you can see it, where over time complexity is accumulating, and at some point it just becomes too much, and then we can start feeling it. We can start feeling the frustrations. So the goal here in this talk, in this topic, is to try to move this line down, to try to find ways to see where is complexity accumulating and be able to managing it better so we can kind of flatten this slope of complexity as it grows. So a few takeaways here. I hope we can find ways to understand complexity better for the sake of talking about it, for the sake of people who are just getting into the API world so that they can understand complexity better, so that it's not something that only the experts can deal with or only the experts can help with, but it's something that someone new to the topic can start getting their hands on it and wrap their head around. I think it's important to have ways to plan for complexity. This is something I feel too we kind of partly do with things like versioning or ways that we manage breaking changes. But I feel like we need more ways to plan how we put complexity into the APIs and how we deal with it as time goes on. I want to find better ways of measuring it. One of the ways that I think is really interesting is by looking at the API schemas. I think there's a lot of complexity that happens there, and we can start looking at that. And I want to look at some of the interconnectedness in our APIs to see how the schemas relate, to see how our resources relate. And if we can change our perspective and look at those differently, I think that we can make better decisions about the schemas that we're changing. A lot of times it's just a big YAML file or it's just documentation, but it would be really helpful to see how everything's relating so that we can make better decisions. And lastly, I'm going to talk about, and I hope the takeaway is that we can start gathering some more metrics around our documents, OpenAPI documents, to get better insights about our designs. So getting into how complexity actually works. I mentioned it's one of those things we kind of experience in the moment and that maybe we know about in hindsight, but we don't have a lot of great tools for measuring it as we're going or good language to talk about it. We kind of rely on this hope that best practices, that good patterns will help us deal with the complexity. And a lot of times it can help in a lot of ways. But we don't have any way of knowing or measuring it. You can actually follow all the best patterns and practices and still end up with a complex API. So if we can find ways to get tangible information about our APIs, we can start looking for complexity in those areas and deal with it. These are some principles that I find helpful to think about complexity to kind of shape the way I look at it. One is anytime that we do any work with our API, there's going to be some form of inefficiency in our work. We're never going to be perfect in the work that we do. So whatever we do, whatever work, there's going to be some ways where we didn't do it perfectly. If we put that inefficiency to our APIs, that's when we get complexity to grow over time. I'll show an example of this as we talk about breaking changes. Another key piece is that complexity doesn't go away on its own. You have to have a plan to managing it. Once you put it in your API, it's just going to always be there. It's going to compound on itself and grow over time. So we really need a plan in order to deal with the complexity that is there and won't disappear. When we feel the effects of complexity, when we feel like it's just too much, or we get frustrated, whether we're consumers or providers, we've waited too long. And eventually, if we don't manage it, it leads to chaos, which is the rewrite or going to a new API. Breaking changes, I think, is a good example of how this works. There are really two different approaches. Of course, there are many, but two main approaches that people have. One is you never remove anything from the API to avoid a breaking change, and you only add optional properties. So it's just you're always building on what's there. And while this does help and make it easier to deal with breaking changes and maybe prevent having to work with consumers, you can see how it adds the complexity without ever taking it out. But again, the other approach is like I kind of just mentioned, is we work with consumers, give them time, help them along to make a change that would normally break their code. But if we wait and kind of work with them, we can reduce or alleviate the breaking change. So there's trade-offs to this. If you keep everything in the API, it builds up over time. If you work with consumers, it has inefficiency to it. It takes more time. It could be time spent actually building more features. So while it does prevent putting some of that inefficiency into the API or some complexity into it, it doesn't mean that it's always the right choice to make. And like I said, if we never deal with complexity, it may lead to a complete rewrite, this kind of chaotic situation where no one feels comfortable making a change to the API. One thing to mention before moving on is that I think that this is all based on trade-offs. I think an important takeaway from that is anytime that we're working with our API or making changes, there's never a perfect choice to make. It's always taking into account trade-offs and making the best decision for our particular context and scenario. So in one case, it may be better to work with consumers. In another case, it may be better to do some of these ways to avoid breaking changes. I think one area we can look at complexity in an API is the API schemas. I call this in the book schema entropy. It's this way that we can think of measuring the levels of complexity in the schema, and it's borrowing the idea of the way entropy works in the world of physics. And there are different ways, I think, of looking at entropy or levels of complexity in your schemas. You can measure all kinds of different things. How many properties do you have? What's the depth of the schema? Is it really nested several different levels, or is it flat? These are next couple areas we'll look at here in a few minutes. Are there lots of inbound references? Are there lots of outbound references? And this last one I want to look at first is how many possible variations of the schema are there? I call a schema variation a valid JSON structure for a schema. So a schema may be short, it may have just a few properties, but it could have many different valid structures for that schema. And in finding a way to measure these variations, calculate them, it gives us an idea on a potential way to see how complex a schema is. I have a little example here. Here is a schema where it's an object. It has one property name, and the name is required. And then I have underneath here the number of variations for this particular schema, and there's just one. There's only one valid structure, and that is an object with a name. Now, if I had a name with an email, but I don't make email required, it's an optional field. Now I've added another possible structure that is a valid JSON structure for my schema. There is one where there's no email, it's just name. And then there's also another one where it is name and email together. And then lastly, I want to show what happens if I add a third one that includes a phone number that is optional and nullable. And we can see here that it expanded up to 6 different variations. You can see now I've got to do one where the phone is null, where there's a phone and a value, where it's all 3, and then where it's name and email, and phone is null. So now we've got 6, and this will grow exponentially. If you have 20 optional properties in your schema, you're going to have over 1 million variations, 1 million different structures. And so what's the takeaway from that? The bugs in our API can hide in these variations. Which one of these variations could cause a problem with your API? Are you able to test all the variations in your API? Usually we're not. We test a few success paths that will maybe help us to work through our requirements and through some scenarios, but we're not able to test millions of different structures. So we can find ways to look at complexity. So maybe that would give us an idea on areas we could start looking. So I think schema variations is one way to measure a complexity, and one way you can calculate it. References, I think, is another way. OpenAPI has a way of doing references, and this right here is a graph that I built of stripes, schemas, and the references between them. You can see it's very complex. Most of the times we just view a schema, or we just view an OpenAPI document as a list of schemas. We don't have this view of how are they all interconnected, where are the ones with lots of variations versus a few. And here we can see that it would be really difficult to get in there and to understand the way the schemas work. But having a way to do this helps us find the complexity, whereas maybe we don't normally have this ability. Maybe we can look at something like this and start pinpointing this area looks really complex because of all of the different references. I have 2 ways of looking at it: outbound and inbound references. Outbound references being you have a schema and it references another schema. And This here is a graph showing Twitter's schemas, and the number of outbound references is reflected by the node size. So it shows the relationships, and then the node size, the circles reflect how many outbound references. And we can see here that the tweet schema is the one with the most outbound references. And there are a few others that are kind of close. And the reason that this is helpful is because the outbound references tell us how likely a change in your API is going to affect this schema or a schema. If the schema has many outbound references, any of those outbound references, a change in those can affect the ones that are referencing it, the schemas that reference it. And a lot of times we don't have that visibility. We don't know how many variations are we adding to this schema, but also how many variations are we adding to every other place that's referenced. And that's an important way for us to measure complexity over time, is just seeing what is the effect of this change. Is it just one variation, or could it be thousands? We can look at it from another way, inbound references, where how many schemas are using a particular schema. And this is GitHub's schemas. I generated this graph based on their schemas and how they're related, and the inbound references. So this big node in the middle is their simple user schema. It's one that dwarfs all of the other ones. It's used over 104 times within their OpenAPI document. And this works the other way as the tweet, where a change to this schema is going to affect 104 different schemas in the document, or 104 different places in a lot of ways. It could be requests and responses. So this is a way to see, if I change this one schema, it could add variations across many different schemas in my API. And having that kind of visibility, having that calculation can help you make a decision, and can help you know the extent of the change that you're making. So measuring inbound, outbound references for our schemas can help us. It doesn't mean that there are problems there, but it can help us look at places that problems could potentially arise, where there could be bugs hiding, where there is complexity hiding. And this is a way to change our perspective on our API designs or our OpenAPI files, to be able to track more information that's there, and to have the ability to explore and drill down to find more granular complexity, rather than waiting for someone to experience it as they're trying to change the API or use the API. Another thing is understanding relationships between resources. OpenAPI has a feature with links where you can link up different operations, different methods within the OpenAPI file. But another way you can look at it is the URL paths. And a lot of people, a lot of APIs use the paths as a kind of hierarchy. I have an example here showing customers with a customer ID and an orders after it. And this has this implied relationship of, here, this will give you the orders for this particular customer. And we can use this kind of pattern to understand the relationships or the hierarchy or how things work in our API, if we can explode these paths and build up relationships. So I have another GitHub example. I really like looking at their API because it's mature, it's been used a lot, and it's got a lot of really great information in it. And this here is a list of all of their nested resources. And you can see that I've only listed ones with 5 or above, and I've highlighted ones that are used 15 or more times. Actions is a really interesting one that's used in 70 different URL paths. So this is one way to have a different perspective. We could take this and build a graph. I think another interesting way is just viewing the URLs themselves in a different way. So Most of the time, we have this URL structure for viewing paths. It's hard to see the levels of nesting here. If we blow this out into a tree, we can see how that's different. We can see how that underneath an actual gist, there are 5 different possible resources with some underneath it. And this one is a very simple one. It only has 7 paths, but repos is obviously one that's going to be a lot more complex because that's what GitHub does. And so they have 130 different paths here that if you just kind of scroll through it, it would be hard to get a sense of how it's actually connected, how it's set up. So we can look at this as a tree and see how nested some of these go. What are some of the more complex areas? What are some of the areas that we may be actually way to simplify them because we keep reusing them, or it's just too deep for us to consider to be a good choice. Of course, GitHub has so much stuff. They're going to have things like this. And they may have a different threshold, different boundary, or a different limit that they put on these that you might have. But it's a good way to think about the resource relationships in our API documents. Lastly, we can just gather really general metrics about our APIs and use that to help us understand complexity. So I showed the Stripe graph of their relationships before. It was very, very complex. And I just pulled some numbers of their OpenAPI document. So there are 71,000 lines of code, and 52,000 of those are devoted to schemas. So a large portion of their OpenAPI document is schemas. You can see they have 412. Whereas when we compare GitHub, they have a very similar, actually a few more lines of code in their document, but their number of schemas is much smaller, and the area in their document devoted to schemas is much smaller. So lines of code doesn't mean something is complex. Numbers of things may not mean something is complex, but it does give us insights to see that Stripe had so many schemas. It had a much more complex graph of the relationships of those than GitHub. And we can see that in a lot of these numbers here. Bringing all these numbers together is a way of finding the complexity in our APIs. So I've gone a few minutes over. I think we have maybe 6 minutes of Q&A, just 5 minutes after I do a quick recap. But the idea here is, can we find ways to measure complexity? Can we start looking at these ways and making up plans on how we'll measure it? Can we maybe tweak our perspectives of the API and look at things differently than we have been by making more measurements? Can we look at our schemas, how they're related, the interconnectedness between the schemas and the resources? And just can we gather some really basic metrics to help us make choices? So I will kind of pause there and stop and just say a quick thanks for listening in. Let me jump over here and check it out. Are there any questions? No questions. Let's see. I'll mention a couple other things. If you have a question in the meantime, as I kind of finish up here, feel free to drop it in even into the chat. I have a few extra links here at the end that are some resources to look at. People who have done some of this work who did so with code software, and so borrowing some of these ideas for the API world. So these people have done some really interesting research. So Microsoft has a lot of really interesting things. And these 2 topics here come from their work around code metrics. If you are interested in any of this stuff, if you're interested in the software itself, please feel free to reach out. I don't have it public yet, but I'm trying to find ways that I can make it available to people. And also, if you're interested in a topic, please check out the book. You can go to apibydesign.com. Let's see, Aiden. How can we explain to our team that we should try to reduce complexity, even if it means breaking? That's a good question. I think kind of one of the meta answers would be that if we can find ways to actually talk about complexity, I think that's a big benefit. Finding some language, I try to promote some language in the book that we can use to talk about things, and some of the things that I've shared here, just different ways to talk about it can help. I think that breaking changes, in the keynote today, they spoke about, they don't do breaking changes, but they have deprecation policies. And a lot of it really involves actually working with your consumers, but making a bit of a lead time between when you announce a change and when you're actually going to do the change. So you do really give your consumers some time to deal with it, and you do it by way of deprecation and sunset and these kinds of methods. Let's see. Kevin, perhaps we can frame discovered complexity as technical debt we didn't know existed before. I think that's a good point as well. I think complexity and tech debt go hand in hand. A lot of times we add tech debt on purpose. A lot of times we add tech debt on purpose, maybe because we're in a hurry. We need to really get a feature out, or maybe we add tech debt and we didn't realize it. And a lot of times it is a feel thing. Maybe it's like a to-do that someone puts in their code that says, I'm really sorry about this. I did it in a hurry. But they don't really say why. And looking at the code, it's complex. It doesn't really give you the feedback on why it's complex. So having metrics can help there, especially with our API. So there's a couple minutes left. I will call it quits here and just kind of wrap up again to say thank you so much for joining in. If this is of interest to you, I'd love to actually chat about it. You can send me a DM here in Hopin. You can check me out on Twitter, and you can go to my website, and I have my email address there. So I'd really love to talk to people about it if that's of interest to you. So please reach out. One last question came in from Vladimir. Have you already developed some tooling for measuring spec complexity during the writing of the API by Design book? I have. I've done some work here on measuring variations, and all the stuff today came out of some of this software, all the data. And so having the ability to capture a snapshot in time of the data and take that data and compare it against the change that you're making is one way to see how it's changing over time. So that is kind of what I'm working on, and I do have some software there for that. So it's time. Thank you all for coming. Thanks for all the familiar names and faces for joining in, friends, and for people I haven't met before. Please reach out. It'd be fun to meet. Thank you for coming too, and have a wonderful day.